Good morning, everyone. Welcome to the session of Data Structures and Algorithm. I am Dr. S. Umarani, Associate Professor, Department of IT, Erode Engineering College. In this session, we are going to see about the introduction to data structures and algorithm. So, what is data structure? We are having some data, whatever it is, whether we are going to do some projects or we are going to form some Excel files, Word file, whatever it is, the main base of that is a data. You want to organize or provide a structure to that data we are having. So, this is called as a data structure. Here, we want to see the definition of data structure. A data structure is the way of organizing the data element that you are going to store in a computer. Whatever the thing is, the base is the data elements, the collection of data we are having, you are going to organize the structure. You are going to organize or provide a structure to that data. That is called as a data structure. So, along with providing a structure to the data, we are also providing a logical relationship between those individual data. So, this is also called as a data structure. And with the help of the data structure, we can able to describe the way the data is stored. So, these data elements provide the relationships between each other for better organizations. For example, if you are going to construct a employee table, in that employee table we will be having more number of data. That is a data in a form of, that is more number of data in terms, we will be having different types of data in different data types with different data types. Name, employee ID, employee salary, so and so details. We are taking only the two details here, Raj and name and the salary. Name is Raj and the salary is 7,000. Here Raj is the character type. So you are having a name as the character data type and salary, that is the float data type. So we are combining the different set of data in this table. So here we are going to make a data structure such that the data of that employee table is organized. So this is a simple example for a data structure. We are going to organize the data in a table or whatever the case it is. That is called as the data structure. Then for arranging the data, you will be having an algorithm. You want to follow some sort of procedure for arranging these data. So that is called as an algorithm. An algorithm is basically a step-by-step procedure that is to be followed for arranging the data so that a desired output will be produced. So there is a problem. In a problem, you will be having some sort of data elements. You want to apply algorithm for that problem and an output is produced. This is called as the algorithm. A set of input is taken as an what is that? An algorithm will take an input as a data and it will organize the data with some form of instructions and it will produce an output. For example, a search. Search is a concept that you are going to search a particular data into the program, into the data element you are having. For that, you want to apply a small algorithm, that is some sort of instruction or procedure that is to be followed so that a search can be done. In the same way, for sorting, inserting, updating and deleting, you will be having some algorithms, that is some set of instruction is to be followed to perform these tasks. So what is the use of DSA? Why we are learning data structures and algorithms? So when we perform data structure, the data search speed will be improved and we can have different number of requests to the particular site so that all the requests can be processed with the help of this data structure and the output will be produced at the earlier stage. And the data structure requires space and the time. So for arranging the data and storing that in a computer, this requires space and the time. Space for storing the data element and the time to perform some specific operations in the data. Okay. So this is called as the data structure requirement. Space requirement and time requirement. So to perform a particular program, it requires space complexity and time complexity. So for each and every algorithm, you want to calculate the space complexity of an algorithm and the time complexity of an algorithm. These are the types, or you can say it is a classification of data structure. Basically, a data structure is of two types. One is primitive data structure and another one is non-primitive data structure. Primitive data structure is a generalized data structure where how the data elements are organized. Either it is in a form of what are the data elements we are having. Either we are having integer data, real data, character data, pointer or logical data. What types of data we are having. So how we are classifying that data. So 1, 2, 3, these are the numbers, and these data are organized under a form of integer data types in such a way. For example, A, B, C, these are the characters. All these characters are organized in a form of character data type. So this is a primitive data structures. So when we use some pointers, all those pointers are taken and it is categorized under a pointer primitive data structures. So in this way you want to classify the data. And another one is non-primitive. Non-primitive data structure is how those are organized. Either it is organized in a sequential manner or it is in a non-sequential manner. So in such way you are categorizing the non-primitive data structure as linear data structure or non-linear data structure. An example of linear data structure is linear list, stack and queue, and for non-linear, tree and graph is an example. And this is primitive data structure. So this primitive data structure directly operate upon the machine instructions. That is how the data is declared. Either it is in a form of int. It is declared in the form of int followed by the variables a, b, c. So you are declaring a as an integer variable. Int b, you are declaring b as an integer variable. So you want to collect all the integer data present in the data elements, and you want to organize all the elements under a integer format. So these are the different representations of a computer. That is, a computer will take the data elements either in a form of integer, float, character, or in a string constant, or at a pointer value. So in these format, you want to categorize the data. So this is a primitive data structure, that is organizing the data based upon the direct operation of machine instructions. This is primitive data structure. And second one is non-primitive data structure. And this non-primitive is a derived part of a primitive data structure, and it will organize or categorize the data in terms of its relationships. Relationship between the integer data, string data, character data, pointer data. In such a way, we are categorizing the data. Here you are going to provide a relationship between each and every data elements. The primitive data structure will be in a form of array, list or files. Whatever it is, it will be in a form of either this case and the linear data structure. And this linear data structure, when the elements are organized in a form of sequential manner, you will be calling this as the linear data structure. And you take an example, array, stack, queue and linked list are the linear data structure where all the elements in these are arranged in a form of sequential manner, one by one. In array, we will be taking only the same data type elements. If you are taking integer data types, all the elements organized in an array will be in a form of integer data type. Here 2, 1, 5, 3, 4, all these elements are of integer data types elements, or you can take a character data types elements. You cannot able to mix the different data types element in case of array. And another term in array is the memory of each and every element will be arranged in a continuous manner. This is an array. So always the array index starts with 0 and end with the last position minus 1. For example, if you are taking the size as 5, it will start from 0 to 5 minus 1, 4. This is array. This is how the array elements are arranged. And stack, the stack is arranged in a form of, this is also a linear manner where all the elements are arranged in a sequential format. In stack, it will follow last in, first out principle. So 1 is inserted first, second is inserted second, and 3 is inserted third, and fourth, so and so will be inserting. The element which is inserted at the last will be deleted first. So that is the case which is followed in LIFO principle. And next is queue. Queue is also a linear data structure where it will follow FIFO principle, first in, first out. Here you are inserting the elements. First element is 3 and the second element is 1 and the third element is 2. So here you are going to insert all the elements and the removal or deletion will be done at this end. Okay. So when you want to delete an element, the first element inserted is deleted first. So this is the principle of FIFO, first in and first out. Next is the linked list. In linked list also all the elements are organized in a form of sequential manner. Here instead of having a single part in a node is divided into two parts. One is used to store the data element and the second part is used to hold the address of the next element. Here also each and every element is sequentially linked so that it is called as a linear data structure. So in a linked list, a node is separated into two parts. The first node is denoted by using the head, and the last node, the second part, is always marked as null because it does not have any subsequent nodes. This is the linear data structure and nonlinear data structure. So nonlinear data structure, instead of arranging all the data elements in a sequential manner, it forms a hierarchical classification. Hierarchical classification is done where the data items appear at various levels. Tree and graph are the examples of this nonlinear data structure. In graph, each and every node has vertex. Each and every node is a vertex. Here this is a node. 0, 3, 2, 1 and 4. All the elements are organized in a form of node basis. 0 is a node, 3 is a node, 2 is a node, 1 is a node and 4 is a node. All the nodes are called as the vertex. And the connection between each and every node is called as the edges. So a graph is the combination of nodes and edges. This is called as a graph. Here all the data elements are not in a sequential manner. It is formed as a hierarchical way. 0 and 3 are at the first level, 2 is at the next level and 1 and 4 are at the third level. So here we are arranging the data elements in a hierarchical manner. Then tree. Tree is also same as a graph where each and every node is connected with the edges. So it is a collection of vertices and vertices and edges. Here each and every edge has two vertices. That is, there is only one edge between two vertices. So this is vertices, and between the two vertices only one edge is connected. This is tree. And this is how the tree can be different from the graph also. Then the most important topic in the data structure is abstract data type. That is, you want to provide behavior for some set of classes or the objects you're having. So for providing a behavior, when we provide a behavior to a type or a class we are having, we'll be calling that as abstract data type. So in definition, we'll be calling as ADT is a type or a class for objects whose behavior is defined by the set of values and the operations. For each and every objects you are having, you want to define a behavior and the operation that is to be performed on that objects. So this is called as the abstract data type. So the abstract data type basically contains the properties of the data, that is the behavior, and the operations that is to be performed on that data. So these are the two things that is to be concentrated in case of abstract data type. So stack ADT, queue ADT, list ADT, these are the types of ADTs available in data structure. We are just considering a stack as an example here. Here, when we say stack as an ADT, you want to define the properties of the stack and the operations that is to be performed in a stack. What are the properties of a stack? A stack has memory allocated to it. These are the properties, and the stack has a pointer called as a top to it. Whenever the element is inserted, that is to be inserted in the top position only. These are the properties. That is behavior of a stack. And what are the operations? So whatever the ADT it is, the main operation is add and remove. That is addition and deletion of an element into the stack. Okay. So here you want to specify. You have specified the operations and the properties of the stack. Then comes, I'm sorry, I did not mention about the behavior. The behavior is how the push and pop operation is done. That is called as a behavior. Next is efficiency. So whatever the algorithm we are performing on organizing the data, for each and every algorithm, you want to calculate the efficiency. So the efficiency of the algorithm, already I said you, the efficiency of an algorithm mainly depends upon the time complexity and space complexity. The amount of time is time complexity, and the storage required for that data items in a computer is called as the storage complexity. Time complexity and storage complexity is measured with the help of this asymptotic notation. The asymptotic notation will calculate the time complexity and space complexity. So when the number of data item is more in case of performing an algorithm, it takes more amount of time and it will take more space to organize those elements in a computer. And this is algorithm analysis. That is, with the help of asymptotic notation, we are going to calculate the time and the space complexity. So in asymptotic notation, there is three types: big O notation, omega notation, and theta notation. This is big O notation representation.
Big O notation is represented by O, and this represents the upper bound of the running time of an algorithm. The function of this big O always lies between 0 and a positive constant. This is called as a big O notation. Then omega notation, this is represented by using this symbol omega. This omega represents the lower bound of the running time of an algorithm. This provides the best case complexity of an algorithm. Here also there is a function, and that function lies above the positive constant value. In the previous section, this function lies between the 0 and this constant value, whereas in case of omega notation, this function lies above the positive constant g of n. Then comes the theta notation. This theta is represented by using this function, this, and this lies between the two values. There is two constant values, c1 g of n and c2 g of n. This theta notation lies between these two constant values, so that it can represent both the upper bound and the lower bound of the running time of an algorithm. And this analyzes the average case complexity of an algorithm. So these are the three forms of notation in asymptotic notation. Then we will see about abstract data type, ADT. Already we have seen what is ADT. This is a primitive data structure. Here we are going to group the same type of or different types of data items. That is called as the abstract data type. In short, we can say this: ADT is a set of objects together with a set of operations. For example, you consider list, set are the objects. The operations performed on list and set are size and union. Then intersection is another object where the operations performed are complement, find. This is called as the abstract data type. There are many forms of abstract data type. In that, list ADT is the first type. Here, what is list? List is an organized collection of items of size n. We can give many number of elements. Those elements are organized in the form of list. For example, we are giving A1, A2, A3 till AN. We are going to form this as a list. Here, A1 is the first element, A2 is the second element, A3 is the third element, AI is the ith element. If I is 10, this is the 10th position element, and N is the last element in the list. Some of the operations to be performed in the list are print list, make empty, find, insert, and delete. What this print list will do is, it will display all the elements present in the list. This make empty function will clear all the elements present in the list. Find, it will find the position of the element. If you are giving a particular element present in the list, it will find the element's position and it will print the position. Then insert. Here in insert, we are going to insert element in a particular position. The input we are going to give for this insert operation is an element and a position. In that particular position, we are going to insert the element and delete. For the deletion, you will be giving the position alone. That is the input for deletion operation. So the element present in the given position is deleted. So these are the operations that is performed in the list ADT. Consider an example list which contains an element 24, 45, 76 and 12. When we perform print list operation, so we want to pass the variable L in print list function so that it will print the list. In some cases, we will be having more number of lists, L1, L2, L3, so on. So that you need to represent the name of the list here. Inside the print list function, you want to pass the function as the variable here. So in the print list, it will display all the elements present in the list. So here the elements are 24, 45, 76 and 12. This print list will print all the elements present in the list. Then make empty. We are going to empty the list. So when you give this function, it will empty. It will clear all the elements present in the list. The next operation is find 76. So what it will do is it will return where the 76 element present in the list. Here for example, 1, 2, 3, in the third position the 76 is present, but you want to consider the first element as zeros position and the second as first, and this is third position. Sorry, this is 0, 1 and 2. So it will return the position of the element given as an input. So So the 76 position is 2. So it will display the position num as 2. Then insert 84 comma 2. What it means is we are going to insert the element 84 in the position 2. That is in the list this is 0, 1 and 2 position. So in between this 45 and 76 you need to insert 84. So what this insert function will do is it inserted 84 in between this 45 and 76 and delete. So delete 45. What it means is the 45 element will be deleted here and remaining element will be printed. The recently updated the list is this 24, 45, 84, 76 and 12. Here when you remove 45, the remaining elements present in the list is displayed. Then implementation of the list. The list can be implemented in two ways. One by using array, another one is by using linked list. These are the two forms of implementation of a list. We will see one by one. First is array implementation of the list. So in array implementation of the list, the elements are stored in a consecutive memory locations. That is, continuous memory locations, the elements are stored. The operations performed in the array are print list and the find operation, and these two operations are more operations are performed. These two operations are very easy to perform, whereas for insertion and deletion, this requires more time. For performing these two operations, the array implementation of list requires more time. Consider an example. This is a list L which contains 4 elements 10, 20, 30 and 40. Since it is an array implementation of a list, all elements will be stored in a continuous memory location. So these are the memory allocation. This is 1001 position. That is the memory is 1001. Here is 1002, 1003, 1004, 1005, 1006. This 10 is stored in this position and continuously 20 is stored, the next element, and in continuous manner all the elements are stored. Here the memory location is one byte. Each and every 1 bit, each and every element occupies 1 bit of position, so that it is stored here. So this is 6 and this is 7, 8, 9, 10, 11, 12, 13, 14. So in 1014th position, the elements are stored, 10 element is stored and 15, 20. In 1016, the element 30 is stored and in 1017, 40 is stored. So this is how the consequently the elements are stored in the array implementation. We'll see some of the operations in array implementation of list, and this is the first one. Here we are going to insert the element 84 in 2. We are going to insert an element 84 in the position 2. Here is the list 24, 45, 76 and 12. In the second position 1, 0, 1, 2. So in this position, in the place of 76, you need to insert the element 84. So you want to move the remaining elements to the next consequent memory location. So the 12 is moved to another location. 76 is moved to 12th position. So that this 76 position is free. You can insert the element 84 in this 76 position. Then deletion of list. Here you are going to delete an element from the list. The element you are going to delete is 45. So what is the thing is, when you delete this 45, then you want to remove this memory location. So that first thing is you want to move this 45 to the subsequent locations, so that it will be out of the memory. You want to delete the space allocated for this 45. So the 45 and 84 is moved here. Consequently 45 is moved here. Then in the next position 76 is moved and 84. When you delete this 45, there will be space here. You want to move all the subsequent elements to the previous position. So 84 is moved here, 76 is moved to 84th position, 12 is moved to 76th position, and after that this position is removed. So this is so you can delete an element from the list. The next is, what are the disadvantages in the array implementation of list? So the disadvantages are, if insertion deletion occurs throughout the list, that is particularly in front of a list, then the array is not a good opinion. So if we need to perform all the moving operations, then we perform the insertion or deletion at the front of the list, so that you are moving for linked list implementation of the list. And this is linked list implementation of list. This linked list is an ordered collection of series of structures which are not necessarily to be adjacent. What it means is, we don't want to store the elements in a consequent memory location. The elements can be stored anywhere in a memory. So basically this linked list is divided into two fields. The node present in a linked list is divided into two fields. First part stores the element and the second part stores the pointer. This element holds the actual data present in the list, and the pointer stores the address value, and that particular address points to the next data where the next data is stored. That address is present in this pointer memory location. Let us see an example of linked list. This is a list. Here all the elements are scattered. They are not stored in a consequent memory location. Each and every element is scattered inside the memory. So this is how you can store the elements in a linked list. So this is the position. This is an element. Previously I said you a node present in a list will contain two parts. First part will store the element, and second part the address of the next element. So this 1010 is the address of this element 20. So this represents the address of the next element where this particular element is stored, where the second element is stored. And the next one is 20, which holds the address of the 30. 1017 is the memory location address of this third element, second element. So 1017. Then 30 will store the address of this element 40. So 1025. So what we will do for the last element? This last element does not contain any more numbers, so that this last element will store null. So instead of the memory location, it will store null. So whenever you find null in the pointer position of the any node, it means that that is the last element present in the list. This is the visualized representation of the list, where all the elements are stored in any manner. All the elements can be stored in any way. So each and every element will have the address which points to the next element's address. So the 10 stores the address of the element 20, and the 20 holds the address of the element 30, and 30 holds the address of the element 40. So the last element will represent the null, which means that this is the last element. So you can specify either the address of the next element, or you can have a link like this. So when you link, it means that this points to the next element which holds the address of this particular element. So this is linked list. So we'll see the operations performed in these two implementation of list. First we'll see the operations performed in array implementation, and then we'll see how the operations are performed in linked list implementation of list. Some set of operations in array implementation are inserting an element into a list, deleting an element into a list, print the elements in a list, searching an element into a list. We'll see all the operations with an example. First we'll see how we can insert an element present in a list. The inserting an element already we have seen. When you want to insert, we are seeing this with the routine. If you want to insert an element in the second position, you want to move all the elements to the next. So that first you want to fix n. Here n is 4. I is equal to n minus 1. So here it is 4. When you count from 0, 0, 1, 2, 3, it is always n minus 1 only. So for the position, this 3, I less than greater than or is equal to position I minus minus. So what it means is, until you are moving these things and the specified position is written, you want to move all the elements to the subsequent locations. So whenever you move, the list is incremented by 1, so that you can insert the particular ith element into the position. So what we are doing here is, so if you want to insert the element 84 in the second position, that is in between this 45 and 76, you want to include a memory location, and you want to move the 12 first and then 76 here. So in the place of 76, you want to insert the element I. So the item is inserted in the list of that particular position. So this is the routine for inserting an element into a list. And deletion. So here you want to delete an element 80. You want to delete an element 84. So if you want to delete an element 84, what you want to do here is, so you want to move this 84 to the, you can delete 84, or in this example we have given the element to be deleted is 45, right? Yes. So you want to move 45 to the last position so that the memory can be removed. So you want to move 45 here and 84 here, then 84 and 75, and in that way you want to remove all the elements. And let us see what are the disadvantages in array implementation of list. Since it is fixed size, the resizing of that particular array is very expensive, and whenever we are doing implementation in array, that requires a continuous memory allocation. Memory allocation should be continuous, and the insertion and deletion operation is very insufficient in this array implementation. There is many wastages of memory, and the insertion and deletion occurs throughout the list. We need to interchange all the elements present in the list, and so that we are moving for linked list implementation. Let us see the linked list implementation. Structure of this linked list is, you are going to create a node for the linked list, and that node contains two sections. The first section gives the data, and the second section represents the address of the next element. So this is the structure of a node in a list. And how can you create a list? So this is how you will be creating n for the n element, for each and every element. So for the total number of elements present in a list, you want to create a node such that that node should be equivalent to the structure of this node, and you want to allocate memory by using an malloc function, and that memory should be reflected to the structure of the node. As such, this structure you want to allocate memory for each and every node, and you want to specify the structure of the node here. There are three forms of linked list. One is singly linked list, doubly linked list, circular linked list. In singly linked list, only one link will be held between each and every element. Whereas in case of doubly linked list, two-way direction of link will be present between the two nodes. And in circular linked list, or in singly linked list and doubly linked list, there is no link between this tail end and the head end. There is no link between the last end and the first node. Whereas in case of circular linked list, the last node is connected with the head node. Even though in doubly linked list we will be having two links, the last node cannot be directly contacted with the node. But whereas in case of circular linked list, you can have the direct contact of the tail node with the head node. Singly linked list, each node contains only one pointer field. So that represents the address of the next node of the list. This is singly linked list. We'll see what are the operations of a singly linked list. So insertion, deletion and search are the three main operations of singly linked list. Insertion can be done at the beginning of the list, middle of the list and end of the list. Same way, the deletion can be done at the beginning, middle and end of the list. This is the declaration of the list. Structure node, data, and the second node represents the address of the next one. So the nodes can be represented in a form of, first node is called as a head, and the last node is called as a tail, and n represents the number of nodes, t represents the particular position. So these are the operations of the singly linked list. We'll see the operations one by one. First we'll see insertion, that too the beginning, insertion done at the beginning of the list. And this is the insertion. Here this is the head node and this is the tail node. So what here is, this is a tail node. What we are going to do here is, the position of the node which is going to the position of the node to be inserted is reflected here. So what you want to do here is, you want to insert the element 5. So where you want to insert? You want to insert at the beginning of the list. So this is null node, that is not mentioned here, whereas here it will mention. So this is a null node. What you want to do here is, since you want to insert the element 5 in the beginning position, so what you want to do, this is a temporary element. So you want to create a temporary memory and allocate this element to this temporary memory, and this temporary memory should replace this head position. The head should be moved as a second next element, and this should be a head element. So this t of next should be pointed to head. What it means is, this head, this need to point this head position so that it will be considered as the second next element of this 5. So that T of next. So this is given to this head. So this is what we have done. Then what we want to do here is T is equal to head. So now you want to consider this T as the head position. You are moving this, you are giving the head position to this temporary element's next element, and this head position will be reverted to this first position. This is what we are doing here, and this is the condition. This particular element is this one, temporary element is considered as the head now, and the previous element, the previously considered head element is the next element of this head element. So this is how we will be inserting an element at the beginning of the list. And insertion at the middle. So you want to insert an element in the middle position. So what we are doing to going middle position, that is what you are going to do here is you want to insert 25 in between this 20 and the 30. That is 0, 1, 2. In the second position, you are going to insert an element. So what is the need here is this 20 should point 20, next pointer should be pointed to this 25, and this temporary element 25 is pointed to the next element 30. Pointer should be pointed to 30. So first you want to create a temporary memory location, and you want to allocate the element to be inserted in the first node, and you want to keep this as null at present. The next condition is, first you want to consider P as the consider an element variable P such that this P of next should be pointed to this temporary element. So that is what we want to do here. So here we have done, this pointer should be pointed to 25, and 25 pointer should be pointed to 30. So that is what we done here. We want to specify now P of next is equal to P. So first you have considered this as P. Now P of next is considered as P now. This one P, and this P should point to 25. So first what we need to do here is, you are considering this node as a T. So P of next is this. So this T is allocated to P of next. So it will look like this now. Then the next thing you want to do here is, you did this. Now you want to consider, you want to connect this and this. So what you want to do for that is, so when you connect these two things, you cannot able to connect this. So when you break this connection, you cannot able to connect this last element with the previous one. So that you don't want to do this first. So what you want to do here is, leave as it is. First you want to consider this. This is P of next. So you want to link this P of next to the temp of next, and then you want to proceed. So that's what you did here. So now the P of next indicates this. This P of next is connected to the T of next. So this P of next is given to T of next, and the next is, so this is done here. And the next position, what you want to do here is, you want to connect these two things. Now only you want to make this P of next is given to this T. So that is what we did here, T. This P of next is given to T. So first don't want to break this. If you're breaking this, that will become a wrong one. So if you break this link, you cannot able to connect this last node with the previous one. So that before connecting this and this, you want to mention P of next is given to T of next, and this one, then this is connected to T. So that is what finally we have mentioned. P of next is connected to T of next. This T is allocated to the P of next. This is insertion at the middle. Then insertion at the end of the list. You want to insert an element 40 to the end of the list. So as usual, you want to create a temporary node such that you want to include the element in the first part, and the second position is null. At present it is null. So you want to link. It is very easy. You want to link at the last. The main thing here is, the last node next pointer should be linked to this T. That's all. The only thing you want to do is that only. So that you are considering head as the P of next. What you want to do is, until this P of next is equal to null, you want to increment P of next. So this is what you did here. Initially if p of next, first this is p, if p of next not is equal to null means you want to increment p by 1. So now the question is here, if p of next not is equal to null, you want to increment this to null. Next, so p of next is moving here. If p of next not is equal to null, yes, it is not is equal to null here, so it is moving here. So once it is equal to null, what we want to do here is this is linked to this, so that is what we did here. The same thing, now the p position moved here, then it is moved here. Only in this state the p is equal to null. So once the p is equal to null, you want to do here is this p of next is allocated to t. So this is what we did. So insertion at the end of the list is done. When p of next is given to t, it will come like this. So this is the insertion at the end of the list. That's all. Next is deletion from a list. How will you delete an element present in a list? So the deleted, first you want to create a temporary node, and deleted element is put to the temporary node. So this is the syntax, a general routine for this. First the head is moved to the temporary node, and you want to clear the temporary node so that the particular list will be empty. So there is two conditions present in this list. One is underflow condition and overflow condition. What is this underflow is when you are trying to insert an element, if a particular list is filled, for in a filled list you cannot able to insert any more element. That is called as an overflow condition. For the completely filled list you cannot able to insert a new element, so that will become an overflow. Underflow means for the empty list you cannot able to delete an element. If there is an element present in the list, you can able to delete. If there is no element in the list, you cannot able to delete. That is called as an underflow condition. So deletion from a list. First is if you are deleting an first element in a list, this is considered as a temp. The head is moved to temp. You want to free the temporary element such that this list will be empty. This temp of data is equal to element. So that particular element is deleted. So you want to break this head, and that head to move, it is moved to the second position. So this is a deletion of element. This head is moved to, head of next is moved to the next position. This is the full routine of the deletion of a list. After deleting this, so this is for an element 10. After deleting an element 10, this is a view. After deleting an element 10, this is a complete view. This element is moved to temporary, and that is set to null. The particular list is empty. Then this temp of data is equal to element. This is element now. So this is moved here, and temp of next is this one, and the next point is considered as the head. And this is inserting and deleting an element from a middle of the list or in between. Here you want to delete an element 20. So what you want to do here is this head of next should be moved to the last element. The thing first, this is moved to temporary, and that list is free. Now the here the element you are going to insert delete is 20, that is moved to temp of data. So for the temp of data it is moved there. Then temp of next, the temporary of next is this one, and that is moved considered as the head now. Okay, and this is what you are doing. Initially you are considering this as temp, and you are allocating this temp to p. Then you are moving the temp to the next position such that you can able to delete this element and empty this particular node. So after this only the particular element is moved to p, and the temp of next is moved to temp. So this is what we did here. So when you delete this particular element, you cannot able to join. So only after joining these things you want to free this memory. So the thing here is, if you are crossing this and you are directly moving, you cannot able to cut this link. So this is a wrong method. So first thing you want to do here is you want to link these two things, and then you want to free up this memory. So when you move this particular element to the temp, it will remove this address position of that particular free memory element. So after deleting an element, this is the position. Then deletion of a list with last element. So the last element deletion is completely easy. Just you are deleting an element and you are making this as null. That's all. So the thing here is P. Until this P of next become null, you want to move that P to temp. Here we are moving just temporary element such that it is moving here, and finally your temporary variable is moved here. So what you want to move here is you want to delete the temporary element, and this is considered as a null element. This link is break and this is considered as a null element. That's all. This is the deletion of the element from the list. The next ADT we are going to see is the stack. Stack is another form of ADT where the arrangement of stack is in this format. Here, the operations performed in the stack are push and pop operations. So the variable used in stack is top. Top is a variable that is used in stack. So the operation, both the push and pop operation performed at the top of the stack. Initially, if we are inserting an element into a stack, it is inserted here only, and second element is inserted here, third element here, and fourth element here. As such, we are inserting. So initially the stack will be in an empty stack. After inserting an first element, the first position will be created, and after inserting second, the second position is created, and so on. Initially the top is in this position. At each situation when we enter an element, the top position is incremented by 1. Here, push operation is called inserting an element into a stack, and pop operation is called deletion of an element from the stack. Both the insertion operation, that is push, and the deletion operation, that is pop, is done at the top of the stack only. See, in stack, insertion operation is performed by using a push operation, and deletion operation is performed using a pop operation. So when we define a stack, generally stack is a linear data structure in which the operations performed is based on last in first out principle. That is, the element which is inserted last is popped out first, deleted first. That is the concept behind this LIFO, last in first out. So a collection of similar data items in which both insertion and deletion operations are performed based upon LIFO principle is called as a stack. So we'll be defining stack in this term. This is called as a stack. Let us see an example of stack. These are the elements we need to insert inside the stack: 10, 45, 12, 16, 35 and 50. So first we need to insert the element 10. So initially just we are creating 1, 2, 3, 4, 5 and 6. 6 memory. Totally we are having 6 elements. So 6 memory space is created for inserting this element. First we need to insert 10. The 10 is inserted first. Here top is present in this position only. The 10 is inserted first and the top is incremented by 1. So the top will be in the second position. Now we need to insert 45. So after inserting 45, we need to insert 12, so that we need to increment the top position by 1. Now the top will be in this position. The 12 is inserted. Then you want to insert 16, so that you want to increment the top position by 1. And the top is pointing here now. The 16 is inserted. Then when we want to insert 35, top position is incremented by 1, and it is 35 is inserted. And when we want to insert 50, top is again incremented by 1 and 50 is inserted. So at present, the top position is present in this 1, 2, 3, 4, 5, 6th position. The top is present. We'll see the operations performed on a stack. The two main operations is push and pop. Push is an insertion operation that is performed in a stack. Pop is a deletion operation that is performed in a stack. Display, to display the elements present in a stack. It will display all the elements present in a stack. So the stack can be implemented as such list. The stack is also implemented by using two forms. One is array implementation of stack. Another one is linked list implementation of a stack. When a stack is implemented by using an array, That stack can organize only a limited number of elements. You cannot able to increase more elements. If we define the stack's array size as 6, you can insert only the 6 element. You cannot able to increase the size of the memory for inserting the extra elements. Whereas in case of linked list, the stack can be organized with unlimited number of elements. So whenever you want to insert an element into a linked list, you can extend the memory size and you can insert. You can create new memory space for that particular list and then you can insert. So there is two forms of implementation of the stack. Let us see it one by one. The first form is stack implementation using array. By using array, this stack can be implemented using a one-dimensional array. Only with the help of one-dimensional array, you can implement the stack. But stack implemented using array stores only the fixed number of data values. You cannot able to vary the size. Once the size of an array is fixed as 6, you can insert only the 6 element inside the array. You cannot able to change the elements. You cannot able to change the size of the array. The implementation of array is very simple when compared to linked list implementations. Since it is a one-dimensional array, the insertion deletion of an array follows the principle of last in first out principle. The element which is inserted last, that is at the top position element, is deleted first. So the element which is inserted last will be deleted first. So that is the principle followed in LIFO principle, last in first out. Always there is a pointer pointing to the stack at the top position, and that pointer is called as the TOP top. Always this top value is set to -1. So whenever we are inserting an element into a stack, this top is incremented by 1. So only after the increment of a top value, you can insert an element. So in an empty stack, top value is set to 1. When you want to insert an element into a stack, this top is incremented by 1. So when top is equal to -1 plus 1, 0. So in an array, the position starts with 0. If there is 6 elements, the position starts with 0, 1, 2, 3, 4 and 5. So when you want to insert an element into an empty stack, the top gets incremented by 1. -1 plus 1 is equal to 0. So the top is present in a 0th position. In the 0th position, you can able to insert an element. If you want to insert another element, the top is again incremented by 1. That is from 0th position, it is incremented to 1 position. In that 1 position, you can insert another element. In the same way, you will be inserting an element until the defined number of space you can insert an element in a stack. Since it is an array, the fixed number of data values can be entered. And deletion. So whenever we want to delete an element from the stack, the top value is decremented by 1. First, you want to delete the top value and the top position should be decremented by 1. So this is what the operations performed in a stack using array. Then these are the steps that is to be followed when we are implementing a stack using an array. The first step is include all the header files which are used in a program, such that the size of the array and some of the other header files that is needed for implementing a stack using array, those things should be included with specific values. This is step 1. Then second step is we need to declare all the functions used in a stack implementation. What are all the functions that is to be used? Push operation, pop operation, all these things should be included in the second step. Then step 3. First, already I said you, the stack operation using array is done only with one-dimensional array. So you want to create a one-dimensional array and that is of fixed size. So for creating a one-dimensional array, you can use this format, int stack size. So you are giving a size of the array in predefined manner, that is, it is fixed. Then step 4. Define an integer variable top. Since the top is a variable used in a stack, you want to use the variable name as top. You should not change the variable name top to some other name. So always the integer variable should be top. So you want to define the integer variable and you want to initialize them. You want to define int top and you want to initialize this top to -1. This is a predefined thing. The top is always -1. Then fifth step is in main method, we need to display the menu such that what operations that is to be performed for this particular function. So those things should be specified in main method. This is step 5. So first we will see what is the steps to be followed in push. Push means inserting a value inside a stack. Already I said you, in push operation, while inserting an element into a stack, first you want to create, insertion is done at the top position. First you want to increment the top position by 1 and then you want to insert the element into the top position. The steps to be followed are: step 1. Before inserting an element, the two conditions to be checked. One condition is underflow and another condition is overflow. So underflow is the two condition. In push operation, you want to check whether we are making overflow. Overflow means if the stack is already full, we cannot able to insert any more element inside the stack. Reason here is, in array implementation of stack, the size is fixed. So you want to check whether the stack is full. To check whether the stack is full, you want to use the top operator and you want to check the position of top. If top is equal to size minus 1, it means that your size is n, means it is 6. For example, if the element to be inserted is 6, means the top position will be starting from 0 to 5. So it is 5. So only you are checking as top is equal to size minus 1. So this is the first step you want to check. And step 2 is, here, if if it is full, we need to display the stack is full error message. Insertion is not possible. And another condition is, if the stack is not full, what we want to do, we need to increment the top value by 1. So that top plus plus is done. And in that particular incremented top, you want to insert the value. So this is what you want to do in push operation. And this is the coding or routine for push operation. This is an algorithm. First you want to check whether stack is overflow. If top is greater than size minus 1, you want to print the error message. If it is not, you want to increment the top value by 1 and the particular value is inserted into the top. And deletion operation. This is called as a pop. So we are deleting an element from the stack. Only the topmost element present in the stack will be deleted. So the steps to be followed in deletion operation is, first you want to check whether the stack is empty, because this is underflow condition. We cannot able to delete an element with delete a stack with an empty stack. So when you are performing a deletion operation in an empty stack, there occurs an underflow operation. So before deleting an element from the stack, you want to check whether the stack is empty. For checking the stack is empty, you want to check top is equal to minus 1. Before itself I said you, initially the top position is always minus 1 before entering an element into a stack. So when the top is equal to minus 1, you can confirm that the stack is empty. So you want to display the in error message that stack is empty, deletion is not possible. If the stack is not empty, you want to delete the top element present in a stack. So for that you want to use stack of top. After deleting, you want to decrement the top value by 1. So these are the three steps that is to be followed for performing a pop operation inside the stack. And the routine for this pop operation is this one. So initially you want to check for underflow condition. If it is underflow, you want to print the error message. If it is not, the topmost element is made into a temporary variable, and the temporary variable is free. That is, you are going to delete the element and removing the free up the memory space allocated to that particular element, and the topmost position is decremented by 1, so that the top will be in a second in the very next element. It will point to very next element. This is the routine for pop operation. Then display message. If you want to display the elements present in a stack, this is the steps you need to follow. In an empty stack, you cannot able to display the element. So you want to check whether the stack is empty. As we seen before, for checking the empty stack, you want to check whether the top is equal to minus 1. If it is so, you want to print the error message. If it is not empty, you can create a for loop such that it need to display each and every element. First, you need to display stack of a, the I is from 0 to n minus 1. So this is the routine. The routine for display is check for underflow condition, and if it is not, while until the top becomes minus 1, you want to print the stack elements. This is the routine for displaying the elements present in a stack. So these are the basic operations we have performed. In the next lecture, we will see about the linked list implementation of the stack. How the same push pop operations are done in the stack with the help of linked list implementation. So till now we have seen about the basics of data structure and what is the abstract data type, what are the types of ADT, that is list, stack and queue. And in list we have implemented, there is three forms of list: singly linked list, doubly linked list and circular linked list. The singly linked list is implemented with by using array and linked list, and in same way doubly linked list is also implemented by using array and linked list. In this manner everything is implemented. And next one is stack ADT. In stack ADT the same thing, it is implemented by using array implementation and also by using a linked list implementation. The operations performed in both stack and linked list are insertion and deletion. So in between, after this insertion and deletion, one more operation we are doing is displaying the elements. That's all. We'll see the rest in the next lecture series. Thank you everyone.